Ooh, orb. First off, it's been a while since I've been in, well, not in front of the camera, below the camera. Yeah, on something that I wasn't trying to hawk you guys. So again, thanks for those of you that stuck with me through that. I thought in Q4 that I'd be able to just continue to push out the amount of videos that I was, and didn't. And so yeah, I kind of just had to throw all those out there at one time. This one's not gonna have that little sponsored thing up on the, I guess it'd probably be down here on the little like thingy where the title is, but yeah. So this one's a little bit different. And what is this shiny little orb that I have here? The other day I was walking around Goodwill looking for some finds, as they say, and I happened across this. And the sticker on it, Goodwill, just says metal. Back in February, but it was the end of February. That's when it went on the shelf. So for $5.18, this looked like a pretty nifty little coffee mug. And then I turned it around and saw that right there. So for those of you that don't know, Ember is a brand of coffee mugs that actually has heating components inside of the mug that keep your drink warm for potentially hours on end. This is one of their travel mugs, so it's one of their larger size. It's got a little spout that opens up there that you can drink out of, a removable lid. And on the bottom, there's some contacts where you can place it onto a charging puck and it charges itself up. So I've actually got one of these, but I've got the smaller, just mug version, something that you can just carry around the house. And this one is meant more so for like taking to the office and things like that. And they're pretty neat, but they usually cost about $100. And for a coffee mug, especially one that has a battery in it that's gonna probably eventually go bad, not necessarily the best deal. I'm not saying everybody should run out and grab one. Definitely don't, unless you can afford one or unless you can find one on a good deal, by all means. This one, again, was only $5.18. Now, it didn't turn on when I got it. This little emblem here is actually a touch-sensitive button, and there's a screen, I forget where it is. It's somewhere on here that lights up and tells you the charge of the cup and tells you how hot it is, things like that. And then these connect through a smartphone app to allow you to adjust those temperatures and get it exactly where you want. I prefer my coffee at 143 degrees Fahrenheit. Don't know what that is in Celsius, so I'll put it up here if I remember. But yeah, that's the temperature that I prefer my brew at. 145 is just a little bit too hot. 140 just feels like it's tepid almost. 143 for some reason, right on the money. Gets it to the point where it feels like it's gonna burn my mouth, but it doesn't, so perfect. Now, this one again, didn't turn on, so I went ahead and took it home and I placed it on the charging puck that I have for my Ember mug and expected maybe something would happen, and nothing. So immediately I was wondering, like, if the battery was just dead in here, wouldn't it at least turn on and like tell me the battery was dead? But nothing happened at all. So I was a little bit concerned and wanted to find out what was going on, and decided to bring you guys along for the ride. So I have already taken this one apart. It comes apart relatively easy, and this is one of the few that you can take apart that doesn't completely damage the device when you do. Now, to get this bottom piece off, there are some push tabs in here that you can push in and rotate, but they actually lock in once they're placed on. It's not meant to be taken apart. Fortunately, all the times that I've taken this apart so far, I have not broken any of those tabs. So here's hoping that I can get that luck again. If I push on it, I think, yeah, it's currently rotated in the right position. Now, it's gonna sound like you're breaking it as you're taking it apart. That's just the plastic pieces going past the little metal nubs here that hold it in. And on this one, I did actually bend one of these out of place this time. I haven't done that before, so maybe I did it wrong. It's only the third or fourth time I've taken it apart, and I did re-secure it the last time a little bit differently, so maybe that has something to do with this. But this little bottom piece is really just a cosmetic cover that covers up the bottom metal here, which is what holds the entire cup together. Now, what we need to do first is remove this metal ring on the outside. It's held in with 4 T5 screws. They are stainless steel, and they are very high quality stainless steel, it appears. They don't stick to my magnets, at least. Oh, that one came out with the screwdriver. But then once you remove those, then this metal ring just comes right off. Now, underneath this metal ring, which we'll set right off to the side here, you'll see two things. There's first this 3D printed ring. So when I first got this mug, the bottom portion here was very loose and it just kind of spun in place, and it was missing one of these gasket pieces. That told me right away that somebody had been in here already. And of course I have at this point, so that's where this came from. It's a piece that I 3D printed real quickly just so that I could fill in that gap and make sure that it wasn't loose anymore. Now from here, there's two things. There's this little retaining plastic ring, which is a split ring, and it goes into a groove on the outer rim of the mug here. And that just keeps this plastic from kind of jostling or wobbling around. And then there's 4 screws here, which are T9 screws. So these come out, and these do have washers on them, assumedly for part of the water resistance, just to make sure liquid does not get into this part as you're washing the mug. These mugs are water resistant. They're not meant to be put into a dishwasher, so they are not dishwasher safe. They're not going to take those high pressure jets, and you probably shouldn't submerge them. I generally don't with mine, but a quick cleaning on the inside and a wipe down on the outside is more than enough, as long as you don't leave anything nasty in there, which I'm just using mine for coffee, so no big deal. Now, from here, we do need to take the inner sleeve out of the mug. Here's that lid, and I think it is actually kind of a neat little piece of engineering. It pushes over anyway and springs back to close. It actually does hold some good pressure in here. It's got a spring-loaded mechanism that holds the pressure, but you can just open it up no matter where you push on it. So yeah, kind of a neat design. Ember did a good job on that one. Now we'll get to what's inside of here in just a moment, although some of you may be able to tell already just from me taking it out there. And we will pull on this inner stainless steel ring to get into the mug. Let's get there we go. So it's only held in place by a friction fit and by those 4 screws that we already removed from the bottom. Be careful when you open this up, because it does have a fiberglass inner lining, and this does seem to be some pretty loose fiberglass. It's something that could get into your fingers, or of course you could potentially breathe it in if you're not careful. So be careful with that. But what we're going to be looking for is mostly on the bottom here. Just to take a look at the side though, this is where that Ember logo was, and this is going to be the capacitive touch, kind of touch point. So you can touch around this area, which lines up with that logo on the outside of the mug. The mug itself, even though it looks like it's a hard plastic, it is actually see-through. So there is the ability you can shine light through this. And that's what happens with this screen right down here on the bottom. So this screen is an LED matrix that lights up, tells you what your battery charge is, as well as a few other stats on the cup as it's running. From here, where once you get it out of the plastic sleeve, you can pop off this one communication pin here, and that's what allows the screen and the button to communicate with the main board. And then there's 2 little tabs that if you pull back, you can lift up on this board. And then it has 2 teeth that fit in on this side. They kind of just slide into the plastic there, and you can just pull them right out. This normally does have a plug here that goes into the battery. I currently have that unplugged because, as we'll see in here, there's not actually a battery, or at least a full one. So this guy was full of very, very spicy pillows, and I didn't want to risk leaving them just chilling. So because of that, I did disassemble the battery completely and found out something pretty neat. Now, this is one of the cells that was left over, and this is the least spicy of the pillows. Now, if you have a device like this that uses these kind of cells, it can be a little tricky to find a replacement. In this case, it used 4 of these cells. It's an EVE, an EVE, which is a brand name, 604134. What that usually means is that it is a 60 millimeter by 41 millimeter by 3.4 millimeters thick battery. So that tells us that this is going to be a specialty type of cell. And when I started looking up to try and find something that matched this watt hours or this amperage, which it is a little over 1,000 milliamp hours here, 1,086, that gave me what I needed to try and find the batteries. And unfortunately, there was no supplier of aftermarket batteries in this kind. There definitely wasn't any that had this form of BMS on them and this type of plug. This didn't really exist. This is something that is bespoke to Ember. The cells themselves, though, I expected I'd be able to find, or at least find something similar. And unfortunately, I came up completely empty. Now, I was able to go directly to the manufacturer. I had to order them from China, but what I was able to find here is these cells directly from EVE, and these are the same exact cells with the same exact dimensions and the same capacity. 1100 milliamp hour versus, in this case, it says 1086, so slightly different capacity, but 604134 batteries, same exact battery for all intents and purposes. These already had some leads soldered off to the side of them, and they did have a BMS per cell. Whereas with the original battery pack, these had tabs that go right into these cells. And instead of being soldered to an individual BMS, these tabs went right from the cells into the custom Ember BMS. You can actually see where I took these off right here, and some of the cells were damaged, or some of the tabs rather were damaged in that process. Now, upon some further inspection here, I was able to see that we do have a temperature sensor here to make sure that the cells are somewhat kept safe, so they don't overheat in there and that it does cut off charging or it cuts off battery power if they do. And then underneath here, there was quite a bit more logic on the board itself, on the BMS. And this is what I assume does some of our balancing. I do see a couple of small resistors here, as well as making sure that we're getting the right voltage from the board. Now this again does kind of go off to this other daughter board where all of them were plugged in, or rather soldered in directly to the pads on this side of this daughter board. Now the only other thing on this daughter board is going to be a fuse. They did have a 45 amp fuse here just to make sure that if there was any kind of trouble that the batteries didn't go kaboom and instead your mug protected itself. I have yet to test that fuse to know if it's any good, but we actually are not going to need it for what I'm going to use this board for here in just a moment. Now, what I've decided to do, and I'm honestly not sure yet if this is going to work or if it's going to be a long-term solution, but instead of taking these apart, removing the existing BMS from each of these cells, and then finding a way to solder it to this daughter board here, instead, I'm going to actually take the leads that they've already provided me, and I'm going to solder them directly to the pads on the main BMS. My thought process here goes like this. First off, we're going to be bypassing this fuse, and that's mostly because we have these BMS on a per cell basis, so they shouldn't be able to put too much power through before the BMS catches them and cuts them off. So that's going to give us our per cell configuration and per cell protection. That's also going to make sure that one of these cells doesn't charge out of bounds if there is something funky going on with the logic on Ember's BMS here. This will also allow us to completely get rid of this secondary board here because I can solder directly to these pads, knowing that all these are the pads that go directly from these individual cells into this board to allow for, again, that assumed balancing. And that'll give me a slightly smaller footprint so that I can fit all of this into the original place where the Ember mug had them, and hopefully get a working mug out of this. Now, at the end, I will tell you why this may not be the best solution. I probably wouldn't suggest running out and trying to find one of these at your local Goodwill. But for me, it might be worth it depending on how well this video does. And then I do have an alternative solution if you wanted to be able to do this on the cheap. I'll get to at the end what these cells actually cost, but yeah, they weren't exactly cheap. I can tell you that much. All right, also first thing up here, we're gonna be desoldering this daughter board. Now I do see that there's a little bit, I can't tell what it is exactly. It looks like some kind of a waterproofing that they're using on here. That's usually what it is in my experience. But we're gonna try and just burn right through that. That's gonna be this blue stuff that we see next to the solder joints. Hopefully I can just burn right through that and go ahead and pull them off. Luckily we've got this on video, but we know that this side is gonna be our positive and this side is gonna be our main negative. And then it's really just a set of series connections from there. Hopefully I can do this without messing anything up too badly here. We'll add a little bit of solder just to get some good contact, and we'll start desoldering the pads here. So I'm gonna attack this big red guy first. And yeah, just like I thought, that is some kind of waterproofing. It's like a silicone almost, but it does seem to be coming up relatively easily. I feel like I'm melting it though, so it's probably gonna stink really bad here and give me some form of special cancer. I forget I can't put my head down here like that. You guys can't see. I don't want to hit this connector over here either. Let me see if I can get that gunk off of there. All right, perfect. seemed like that worked. All right, so we took them off just like this, which means, again, our positive is on this end, main negative is all the way over there. So there's a couple of ways that we can do this now. Now, what we need to do is, again, a series set here. I do need to first verify that we've got good voltage on all these cells. Let's be smart about this and do that part right at the very least. I've got a good feeling these are going to be pretty similar across the board. They usually do balance them before they get them out to customers, but you never know. 3.912, the 3.885, 3.899, 3.905. Yeah, so these are all very, very close in voltage range. So I'm not too concerned with needing to balance them further. I'm still interested to see how these are going to work together. If this BMS is going to give conflict or interference to the other, or exactly what I should expect there. So leave it in the comments if you think you know what's going to go on here. What's going to happen? Am I going to be opening this cup back up here in a couple of weeks just to fix this, or what? There we go. Sorry, I had to get in your way to do that, but there we go. We now have connection across all of the cells. What that means is that, in theory, if we were to probe against this, owie, if you don't stab yourself first, we should see main negative here, main positive here, and have 15.59 volts. That's exactly what I wanted to see. That is fantastic. So now that we've got that done, again, we're looking at our circuit board here, which has our kind of pigtail of different batteries that are connected to it. And we now need to get this back into the cup somehow. So to get that accomplished, we will move our nose big helping hands out of the way. Again, not technically here to sell you guys anything, but if you do want one of those, I put all my tools down in the description. Feel free to check it out. And let's get our cup back in here. Now, we have a relatively limited amount of space that we need to be able to accommodate this in, and we also need to make sure that we are keeping our circuit board at a place where it can be plugged in to our main plug here, as well as to the battery. All right, so we've got our little battery pack here with a mess of wires off to the side. Again, I'm really hoping that I can get this in there in a way that it won't impact the use. I need to get one more string of Kapton tape here just to cover those contacts again, make sure everything's good there. And then for the sake of it, I'm going to put one more across this way. Again, all we're really doing here is reinforcing our joints. Oh, and I do hope that there's enough space in here. It's going to be fun if not. So that is our little battery pack. Again, this little bulge off to the side is what currently has me a little worried. So let's see if this is going to fit in there, or if we're going to be taking something out. So it actually seems like it wants to. Oh, yeah. And in fact, I was able to get it down in there. So it's actually very tight in there right now, which not necessarily a bad thing. There is no heater on the bottom of this cup. It is just the sides that are heated. So the bottom doesn't have, to the best of my knowledge at least, any kind of direct heat that's going to be hitting this. And then there is that temperature sensor that now is on the very bottom. So that should, in theory, protect it. Let's see if we actually get a working cup now, though. I'm interested to know if this is going to work right off the bat, or if there's something we're going to need to do, like plug it into a power source before we can get it functioning. It's clipping in all nice here. Oh, I did trap one of my wires underneath the circuit board here. Let me pop that back up. Let that loose. There we go. Didn't cut it or anything, so that's good news. So we will pop this guy, hopefully the right way around in here. It'll only go one way. Hey, and it did work. Moment of truth, I think. Again, I don't know if it's going to work until we plug it into power, but anything? No, nothing. So I'm afraid that is a little bit disappointing. I don't know, again, if that is because it requires power. This does take, it takes 19.5 volts to charge. So I could, in theory, put 19.5 volts to these bottom pogo pins and see if that will activate it. But there may be a deeper issue with this unit that I was not aware of. So we would need 19.5 volts to kind of get it up and running here. Are we going to tell me which one is positive and which one's negative? That would be too easy, wouldn't it? Do we just test it and go for it? I can put just such a small amount in there, maybe. And I'm curious if there's something here that's being tripped because it's not currently plugged in. Oh, there is, I forget, a reset button on the bottom here too. No, nothing. There doesn't appear to be anything special in the bottom of the cup here. Maybe it is looking for some kind of a resistance on these coils before it'll power itself up. I don't know. We'll pop it into the cup here real quickly and see if we get any kind of different behavior. Hey. Oh, we've got something going in. I just got a screen. It's showing me a nearly full battery right now. I'm putting in 0.5 amp. So 7 or 8 watts, nothing major. Oh, that was cool. So let me see here. Oh, we've got a screen, guys. I think we fixed it. Can I turn it on? Is there anything I can do from here? I don't think there's anything I can actually do from the screen I'm at right now. Oh. Ember. Oh, you have to touch right on the thing. Okay. So if I touch and press and hold. Off. Oh, it asks me if I want to go off. If I keep holding, does it go into Bluetooth? Pairing mode. So in theory now, I should... All right, so it's now searching for a new device. It does say Travel Mug. Let's confirm pairing here. Come on, baby. This is awesome. I do need to open it back up one more time. There was a piece that was missing out of the bottom, a small piece of foam that kind of holds the battery in place and makes it a little bit more rigid, because right now it is bouncy just a little bit. So now we've got it paired. It does show again cold because there's nothing currently in it, so it's not going to show warm until there is some warm liquid in it, but it should confirm here. And there we go. So I now am paired to this device. Let's see if there's any kind of software update or anything ready for it. It knows that it's empty, says that there's 80% battery, so that's good news. Doesn't appear to have any kind of software updates or anything like that, so it's pretty much just ready to go at this point. 143 is my temperature, so it automatically tries to set it to that, and I see 143 there as well. So that's great. It's telling me now it's 86. Makes sense for the warehouse. That's about right for what I'm used to seeing here. Let's turn our output off on our power supply. So yeah, we're up and running. We've got this guy back working. Let me see if I can't find that other piece of foam so that we can go ahead and tidy this up completely. There we go. Now, as I alluded to before, this isn't something that I would really suggest that most people tackle. It is not an economical venture, at least the way that I did it here with these batteries. In total, these batteries off of AliExpress to get them shipped to the US cost me about $48. So that, in conjunction with the price of the actual unit itself, really makes this not worth it. So I wouldn't suggest doing this. I wouldn't suggest going out to buy these with the attempt, or with the intention rather, of fixing them up and either reselling them. Maybe if you wanted to use one yourself and didn't want to pay the full $100 price that they ask for them, that might, I guess, be something that you could justify a little bit more easily. But again, for, at this point, 45 bucks, there are alternatives these days that you can get online that are going to provide you the same experience as an Ember mug for around that $40 price point. And you're working with a brand new device, not having to worry about potentially screwing something up here. So that would be my suggestion, would be to go after one of those. I really like my Ember mug, and hey, it just said hello to me actually as it came on there. I really like my Ember mug. It does work quite well. The ones that I have at home I've been using now for a couple of years, and they work great. They keep my coffee warm until around noon actually. So I get 4 to 5 hours worth of usage out of it every single day, and they work pretty flawlessly. These are the only ones that you can actually kind of take apart like this. The rest of the Ember mug line, you have to destructively take them apart to be able to remove all of the components and get into the batteries. So this one may be the best of those models, but it's still not easy and it's still not economical. When you look at the cost that it takes to actually repair one of these, it doesn't normally make sense. Now, I alluded to before that there is an alternative way to fix this that would not have all of that added cost. And what I was thinking of doing there, if this fix didn't work, which unfortunately, fortunately, maybe something we can revisit at a later time once we, if we find another one of these. This unit ended up working fine, but if it had not, my plan was actually going to be just to put a USB Type-C port on the side of it that allowed it to accept in 19 volts full time and charge, or rather function off of that. It would not have any charge off of the coaster, but it would allow you to plug a USB port into the side of it, keep it hot, keep your drinks hot. In theory, and definitely, it wouldn't have a time limit like the battery does. But ultimately, since the battery option did work, I'd much rather have that convenience. So I'm going to keep it as is and not attempt to destroy it any further by putting a USB-C on it. If I can find another one of these at Goodwill, or if any of you come across one and you see it on eBay or something, shout me a message in the Discord. For those of you that don't know, I did recently open a Discord, and those that were among the first to join did get some special permissions. But really, it's just a way that you guys can reach out to me if you see something that looks cool, or I can, of course, reach out and share things, just in case maybe this YouTube thing doesn't last forever. Who knows? All right, that's about as good as we're getting. So the bottom, nice and secure now. I guess we can go ahead and take our 518 sticker off, which of course left us some nice goo behind. We'll get that up here. Just so you guys know, sticker removes sticker. So if you've got a sticker that leaves you some goo, usually you can get it back off doing that. And yeah, I'll clean this up a little bit when I get home before I put any coffee in it. You can see the inside's pretty clean. Got a little bit of marking on the inside there. But yeah, that's it for our Ember mug. We are, again, working again. I'm kind of surprised, to be honest, that that's all it was just the battery. It's kind of expected with a lot of devices like that these days, where the batteries are going to go bad in them, and instead of fixing them, people are just going to throw them away. So you can get something like this for about $5. Spend 40 bucks on some batteries, or spend $5 on a little USB port that you can put in the side here, and get yourself a nice working coffee mug that will keep your beverage nice and hot. So yeah, I'm going to test this thing out over the next couple of days and get some nice warm beverages in it, and I will follow up and let you all know how it worked out.